My name is Dr. Charles Van Est, and I am with the Center for Energy Systems Research here at Tennessee Tech. My project is delivering power to agricultural sensors, and the idea is to produce sensors that don't have batteries in them. And so if we can do that, then you can have a lot more sensors throughout a field. And so the way that we're going about that is we will be applying power to the soil and transmitting it over a large distance. I've been working on this project for about 4 years now, but we've just gotten the funding with NSF last year. To make the system work, we have two connections that we make to the ground, one up at the surface and one below the surface. And we produce a impulse of current through the ground. And what we found is that current creates like a donut, and it donuts out, like a water droplet falling onto still water, yeah, and it ripples out. And so by far away, by connecting two other contacts in the ground, we can capture that ripple and use it to power devices. So far we have dug the well, we've set up we call it the transmitter, the two contacts that are made in the ground. We've set them up. Those are connected to a solar panel grid. And so that solar panel, it's a shed, that solar panel shed allows the energy to go from there into the ground to distribute it. We are currently taking measurements of how far these ripples, these ground ripples go. We've been able to measure it up to about 800 feet, and we are working on pushing that even further. It takes approximately a few hundred milliwatts, so maybe 0.1, 0.2 watts of energy per sensor in the field, and we'll be able to deliver a lot more than that to the surrounding area. Our next step is we want to improve upon it. Right now, with only the one system, we kind of do a single ripple, so the energy spreads out everywhere. By having multiple wells, we'll be able to steer where that energy goes, and with that, we'll be able to bring it to a next level. We also want to work more on the efficiency side of things, since this well in particular is set up to effectively look at just the physics or the phenomena behind it. So for the project, we're collaborating with the University at Tennessee, and we're also collaborating with the University at Buffalo in New York. Buffalo is currently working on sensor modules that they'll be building, and then we'll be taking those modules and plugging them into the ground and collecting data with them, and that data will be analyzed by the University of Tennessee. We were inspired by Nikola Tesla for sure, because I've always read about how he was able to transmit. He always claimed that he could transmit through the earth, and to this day no one really knows what he did or if that was even possible. And what this research is showing is that there is at least a body of precedents that does allow us to send power. Maybe it's not over the entire planet as Tesla claimed, but it definitely can be regional. And the ultimate goal, the ultimate benefit is to allow farmers to strategically understand their soil and be able to identify what parts of their fields need to be watered or need different nutrients, with the end goal of being able to take and deliver fertilizers over on this side of the field where the other side of the field doesn't have to. Currently, they have to put fertilizers over the entire field. So this could really save not only time, but expense and money, and really bring about precision agriculture.